Hi folks, my name is Mas for YouTube channel Lockmaker360. I'm building a playlist about Arduino fundamentals, and in the last video we looked at libraries, how you can find and access library functions and stuff like that. And in this video we take a look to buttons, because on the hardware side buttons are great to select something or to trigger an interrupt. And first we looked at the Arduino. Here we have 14 digital pins. They are mapped from 0 till 13. And over here we have 6 analog pins mapped from A0 till A5. The difference between our digital and analog pin is that our digital value only has 2 stages, like true or false, low or high. It's on or off, 0 or 1, and analog values. If you read on a analog pin, you can read a value between 0 and 1023, and we can write to a analog pin a value between 0 and 255, and this is limited because the bit setting. And if you want to know more about bits, and watch this video. Buttons can be pressed or unpressed, so we need a digital pin for this, because the button state can only be on or off. So I chose digital pin number 7 and I set the pin mode to input, and I also set up an LED on pin number 13 and set this to output. And inside the loop we built another integer, and every time we loop, this integer gets the value from the button, from the push button, and we write this value inside the serial monitor. And for good order we delay for 1 millisecond. If the value is equal to 1, we set the LED high, and if it is 0, we set the LED low. And we also set up a counter. And every loop we increase this counter by 1, and if the counter is equal to 60, we reset the counter value and we print to a new line. So we write down in the serial monitor lines from 60 characters. Here we are in the Arduino simulation software, and I set a push button to pin 7, as you see over here, and a LED to 13, and I open up the serial monitor and I wrote this sketch to show you how fast the Arduino Uno is. The clock speed from an Arduino Uno is 16 megahertz, and that's brutal fast, because this means 16 million cycles per second, or an Arduino Uno can handle 16 million operations every second. So even in this slow simulation software, if I run the sketch, so you see here in the serial monitor that the Arduino writes down every loop the button state, and you see it's looping very fast. And if I press the push button, even if I just tip the button for a split second, and you'll see that the Arduino was reading in this split second a value of 1 on the pin for more than 60 times. And it's very good to be aware that the Arduino is measuring way faster and sensitiver than we humans interact with it on the hardware side. I wrote a small program which listens to the button, and if the button is pressed, then it set the LED high. So this is the button, this is the LED. If I press the button, the LED burns. But if I touch the wire here, the LED starts burning as well. So the button is listening to the code, but this issue made the code not trustful. And that issue is called bouncing. And this is the signal. When the button is pressed, the signal gets high. These are the cycles between the lines. What happened if you touch the wires? Then there is noise in the current and you get a bounce between 0 and 5 volts. And sometimes the Arduino reads a difference and it thinks it's high, and then it starts burning the LED. A low signal is very sensitive for bouncing, and to fix this we set the signal high Inside the code, we set up the monitor. We set the button to input and the LED as an output. And then we write inside the setup, we write a high voltage to the push button. And this can be a little bit confusing because we set it as an input and we write a high voltage. And what this does, this is enabling the pull-up resistor inside the Arduino. So this is the button connected to the ground and connected to the input pin. And we set the input pin high, so the Arduino puts 5 volts on it, and it put the resistance in there. So this is all inside the Arduino, and the Arduino is reading all the time on the input pin. And because the current flows to the button, and if we press the button, the current flows to the ground. And on the moment we press, the Arduino reads a different value, and then it knows it's pressed. But the only problem is we have to think backwards, because the Arduino is reading a high voltage all the time, and if we press, then it reads a low value. So we read the button state, and we write down the button state, as you see here in the monitor. And you see it's high, it's 1, but the LED is not burning. So here in the code we said if the button state is low, then the button is pressed. So if I press the button, it says the button is low, and as you can see, the LED is burning. Arduino made a special statement for this. You can make the pin mode of the button, and then you can write input pull up. And what this does is it combines these two lines of code and this one. But now you know the background of if we make it input pull up, why we switch the button state to 0 instead of 1. And in the second example, how to build a on and off switch, we have to take care with debouncing. And debouncing is, you saw how fast the Arduino was cycling, and those lines are cycles. The Arduino is reading, and it reads low, 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 and then here in this cycle it's not low and it's not high, and that can be some noise, like a cell phone is too close to the wire, or probably you're touching the wires or whatever. Because our microcomputer is cycling so fast, it's reading a difference, and probably it will jump too high while the truth is low. We cannot trust a bounce in one cycle. To secure this, we program it in a way that we are not reacting on one cycle, but we react on a debouncing time of 50 milliseconds. Inside an Arduino, under the hood, in the background, there is an internal clock, and as soon as we put power on the Arduino, this clock will run, and after 50 days it will reset itself to 0. But we can access this clock with a function called millis, and this returns a millisecond value for how long the Arduino is running, and we can use this value to calculate with. So we store 50 milliseconds inside the bounce delay, and over here we check or the time that the button is pressed minus the time that the last time that the button was pressed is bigger than 50, and if that is true, then we switch from LED state. And this is a good example how much control you have with your Arduino. You can make the delay time as long as you want. For example, you can set the time to 3 seconds, so you have to press the button for 3 seconds before the if statements are true. This is inside the monitor. If I press the button, see the LED is on, and if I press again, LED is off. It works very stable. And this is the end of the video. Please leave a comment if it was helpful. In the next video we're going to talk about how we can translate our sensor input to a human readable value. Like we have a temperature sensor and there is an incoming value, and we're going to translate this value to the temperature in Celsius. Please subscribe to my channel. Have a look on Lockmaker 360 to see more videos about sensors, and Arduino fundamentals. Thanks for watching.